Now let's nerd out a little bit more with the sample space. So before we get started, I want to actually write out the definition of the sample space, just so we have it. So I like to think of the sample space as the set of all outcomes of an event. And we can use the sample space to help us figure out probabilities, and we can also use it to help us think about how to build a simulation in Python. So remember, if we're looking at the probability of a certain outcome, that's just going to be the number of that outcome divided by the total number of possibilities. So if you have the sample space all listed out, you can count how many possibilities there are and then count how many of those outcomes there are to find the probability. And like I said, sometimes it's helpful to actually list this out. Sometimes that can be incredibly tedious, especially if it's something that has a lot of possibilities. Like, Wade, I think we mentioned playing a game of tic-tac-toe.
Thousands and thousands of possibilities.
That would be annoying to write out. But something like rolling a die would be really easy to list the sample space, and even rolling two dice. And so for puzzle 1, it says there are 36 ways for the dice to fall if we're looking at rolling 2 dice. And I have all 36 of my possibilities here. I have die number 1, so the die that I roll first, and then die number 2, the die that I roll second. And looking at these possibilities, it can help me figure out the probability of certain events. So for the first one, it says, what's the probability of rolling 2 dice and getting a sum of 4? So I'm going to go ahead and write this in probability notation. We have the capital P is read as the probability of, and then the event is getting a sum of 4. So Wade, if you were going to roll these, what are all the possible ways to get a sum of 4?
So if I think about the dice, I'd say the first one might be a 1, and then the second one would have to be a 3. Then if the first one was a 2, the second one would have to be a 2. And if the first one was a 3, the second one would have to be a 1.
Exactly, and I think that's it, right?
I think that's it, yeah.
So that's 3 outcomes out of 36 total possibilities, and I could write my probability like that. And a lot of times, if you weren't given the sample space, you would kind of just think about it like Wade did, like, okay, what are all the options that I could get? But if we have the sample space, like we do right here, I can just look and say, oh, this is a sum of 4, this is a sum of 4, and this is a sum of 4. And so I can look and see my probability is indeed 3 out of 36. We can do the same thing for getting a sum of 10. What's the probability of getting a sum of 10? And I know the denominator is going to be 36 because I have 36 possible outcomes. And then we can also think, what are the ways we can get a sum of 10?
Yeah, so it's a lot bigger, so there's probably more possibilities. Like,
ooh, let's see.
I'd have to get a 4 and a 6.
4 and a 6.
5 and a 5, or 6 and a 4?
And I think that's it, right?
Yeah, it seems like there should be more, but I think that is it.
I think that is it because there's more ways to get a sum of 10 if we're not dealing with dice. Like we could get a 9 and a 1, but that doesn't work with dice. So that's also 3 out of 36. And if I'm going to get rid of this, if I wanted to look at those on my sample space, here they are. And the very last part of this puzzle actually says, what's the probability of the second die having a value of 4 or greater? So what's the probability of die number 2 being greater than or equal to 4? So this is kind of interesting because it's basically saying we don't care about the first die, right? There's no conditions on the first die. So the first die number 1, can be anything. But die number 2, if we look up here at die number 2, it has to be 4 or greater. So here are all of my options where the second die is either 4 or greater. 4, 5, or 6. And it looks like that is just half of the outcomes, right? So that's going to be, if we count all these up, this is going to be 18 out of 36, or 50%. So looking at the sample space of rolling 2 dice kind of shows us that if we want to write it out, it makes calculating our probabilities a little bit simpler. There is one more puzzle that we're going to do, and this is actually Wade's favorite question.
Yes.
So this is the question where you roll 2 different fair 6-sided dice at the same time. And actually, we want one to be blue and one to be red.
I've got a red die.
Perfect. And we want to know, what is the probability that the blue die lands on a 4? So I'm going to write this out. What's the probability that I get a blue 4 or a red 2.
So not an or. So if we only care about the blue die if it lands on a 4, and if the blue die doesn't land on a 4, we care about the red die landing on 2.
Exactly. So we could solve this problem a bunch of different ways. Wade and I have actually given this problem to our classes a lot of times, and we found that there were, 5 or 6 different ways to solve this problem?
A lot of people come up with a lot of different answers.
Yes, and one of the ways that we have seen is through the addition rule, because this is an or situation. We could say, okay, the probability of a blue 4 or a red 2, we could use the addition rule and say that's just the probability of getting a blue 4, or means to add, plus the probability of getting a red 2, minus the probability of both. But that seems like a lot. I don't really want to do all that.
It's 3 different calculations.
Yeah, it's too much work. Instead, why don't I just use, if I have my sample space, I should just go ahead and look at it. So I am going to look up here, and I want to know what's the probability that I get a blue 4. Let's just call die 1 the blue and die 2 the red. Doesn't matter which is which. But I want to know what's the probability I get a blue 4. So here are all the options. Looks like there's 6 options where I get a blue 4 or a red, what was it, a red 2? A red 2. Thanks. So there are 6 options as well. And I want to make sure when I circled all the options, this right here, getting a 4 on the blue die and a 2 on the red die, actually is included in both of them. So I don't want to count that twice. So when I'm counting all the possible options, I actually want to only count that once. So I have 1, 2, 3, 4, 5, 6, 7, 8. I don't want to count that again. 9, 10, 11. So it looks like I had 11 options of getting either a blue 4 or a red 2 out of 36. And this is actually one of the ways. We said there were 5 different ways that students solved this. And one of them was just listing out the sample space and counting the amount of successes. So again, this works if the sample space is reasonable to list out, or if you can find a way to do it in Python. But sometimes it can be really complicated to list out, and it's better to use programming to solve these questions.